Okay, so let's get started. In this session, we take a look at the idea of finding the area under a curve, and that looks somewhat different than what we've been discussing before, but we'll see how that connects. Okay, so Archimedes himself took a look at this problem of finding the area enclosed by a circle or enclosed by a polygon, the area under a parabola, and so on. Could be found by methods that he developed, but unfortunately, when the when the Greek kingdoms fell, people forgot, so the idea of this sort of forerunner to the integral calculus actually had to be rediscovered. Okay, so there's a few results that I'm going to use in this session, and I'm just going to give them to you first so that we can use them later. So the first result is if you want the sum of the first n positive integers. So if you want 1 plus 2 plus 3 plus and so on up to n, then the result of that summation is 1/2 n times n minus 1. This can be proven either through geometric arguments or by mathematical induction. But for our purposes, we take this as a given. So summation I equals 1 to n I, that is 1 plus 2 plus 3 plus 4 and so on up to n. That's equal to 1/2 n times n plus 1. Okay. The sum of squares. So if I'm adding 1 squared plus 2 squared plus 3 squared up to n squared, that's equal to 1/6 n times n plus 1 times 2n plus 1.
Sir?
And so we're going to use these two results later on. Okay?
So can I ask a question?
Yes.
Sir, what if if I want from 40 to 60, will I find for 60 first and then find for 40 and subtract both?
Yes, you could do that.
Okay, sir.
Okay. So let me remind you of the area of a rectangle. Okay. All right. So if I have a rectangle, it has a height h and a width w, then its area is h times the height times the width, h times w. Okay. And what if I have a whole bunch of rectangles? I lay them down side by side, and the first rectangle has height h1 and width w1. The next one has dimensions h2 and w2. The kth one has height hk and width wk, and so on. Then how would you find the area enclosed by all of those rectangles?
By adding the height, multiplying the heights and their widths, lengths and widths, and adding
That's right.
the
So h1w1 plus h2w2 up to hkwk and so on all the way up to hnwn. So if I have n rectangles and I'm laying them side by side and I want the total area enclosed by the rectangles, I add up the widths and add up the height and the width, height times width of each rectangle. I add up all the areas of the individual rectangles, and I will get the total area enclosed by the rectangles. Okay. Okay. So now let's say that I'm going to put the rectangles, I'm going to put these rectangles, they're going to sit on top of the x-axis, running from A to B. So the first rectangle, its left endpoint is at x0 is equal to A, and its right endpoint on the bottom is at x1. The next rectangle, its base runs from x1 to x2. The next rectangle, its base runs from x2 to x3. and so on and so forth. A typical rectangle, its base runs from xk minus 1 to xk. And the last rectangle, its base runs from xn minus 1 to xn, which is b. So if I take the interval from a to b, and I chop it up into subintervals, n subintervals, right? These xi label the points, and the distances between xk minus 1 and xk is the width of the kth rectangle. Okay, there's a question?
Yes, sir, I did not get this part. Like, what are we calculating here? Are we still relating this to the rectangle or something?
Yeah, these are the points that give you the width of each rectangle.
The width of each
Yeah.
rectangle.
So yeah, I've got n rectangles. They're laid side by side, right?
Okay.
They're
Yes.
all next to each other, right, adjacent to each other. And the base of the total runs from x0 is equal to a to xn is equal to b. So they cover the interval from a to b. And then I've divided them. I have n rectangles. So the first rectangle runs from x0 to x1. Its base on the x-axis runs from x0 to x1. The second rectangle runs from x1 to x2. The kth rectangle, its base on the x-axis runs from xk minus 1 to xk. And the last rectangle runs from xn minus 1 to xn is equal to b.
Okay, sir.
Okay. All right. So let's say, so I've got these n adjacent rectangles. The base of each rectangle lies on the x-axis, right? The total figure, the base of all of them put together, run from A to B. And the height of the kth rectangle is yk. So the height of the first rectangle is y1, the height of the second rectangle is y2, the height of the kth rectangle is yk, the height of the nth rectangle is yn. Okay? Okay, so then what's the total area? Well, you add up the area of each individual rectangle. So the height of the kth rectangle is yk, and its base runs from xk minus 1 to xk. So the difference between that is the width of the rectangle, which is xk minus x sub k minus 1. And then you sum them all up. You sum from k equals 1 to n, and that gives you the area of n such rectangles. Is that okay? All right.
So could you explain this again?
Okay. So we had this formula. If you have n rectangles and they're adjacent to each other, right? And then how do you get the total area enclosed by the rectangles? You add up the individual areas of each individual rectangle. The height of the first one is h1, and the width of the first one is w1, okay? So you add h1, w1. The height of the second one is h2, and its width is w2. So the area enclosed by both of those rectangles, which are side by side, is h1w1 plus h2w2. And you just go on adding up you add the area of each adjacent rectangle, and that will give you the total area enclosed by the rectangles. Okay, so here I'm saying that the height of the kth rectangle is yk. So I'm putting them in the xy plane. The bottom of each rectangle lies on the x-axis, right? And the width of the bottom of the kth rectangle runs from the point xk minus 1 to the point xk. And the height of the kth rectangle is yk. So the area enclosed by the kth rectangle is the width, which is which is, sorry, it's the height times the width. The height is yk, and the width is xk minus x sub k minus 1. And then you sum them all up, and that will give you the area enclosed by n rectangles, which I'm calling A sub n. Okay.
Sir?
Yeah.
Sir, so basically it is the area of kth rectangle only, because, right?
There's this is the area of the kth rectangle, and I'm summing all those areas from k equals 1 to n.
Okay.
Sir,
So
why are we
basically, it's
subtracting
the
xk minus 1?
Okay, because the kth rectangle, its right bottom corner is at xk on the x-axis, and its bottom left corner is at xk minus 1. And so the
Okay,
distance
sir.
between them is the width of the kth rectangle.
Okay, sir, got it. Thank
so
you.
sir, this formula gives us the total area of the rectangles from x is equals xk to xn.
Yeah, it gives us the total from x0 to xn. Yeah.
Xn.
Yeah.
Yeah. Okay.
Sir, will this derivation be included in our exams?
I don't know. Well, why don't we just learn this because we want to learn it instead of, okay, it might show up on an exam.
All right.
Okay. So let's find an area that we already know. Okay. The area of a triangle. Okay. So the triangle runs from, its base runs from x equals 0 to x equals 1. That's the bottom. Then there's a line segment at x is equal to 1, a vertical line segment. And then there's a diagonal line, y is equal to x. Okay? So that's how you bound your triangle. Okay? So in this case, what's this point that I call x0? Okay.
The origin.
The bottom left corner of the triangle is where? It's at x equals 0 and y equals 0. It's at the origin. So x0 in my formula is 0. Where's the right end of the triangle?
X is equals to 1.
X equals to 1.
X is equal to 1. So xn in my notation, this xn is 1. Okay? All right. So let's say I'm going to divide up the base of, what I'm going to do is I'm going to cover this triangle with rectangles. And I'm going to try to approximate the triangle, the area enclosed by the triangle, with rectangles. Okay? So I'm going to have n rectangles of the same width. Okay? So if the base covers from x equals 0 to x equals 1, so if I divide that up into n subintervals, what is the width of each subinterval?
1 over n.
1 over n, right. Okay? And the way I'm going to draw my rectangles is this. So the base is at, say, the base of the first rectangle runs from 0 to 1 over n. The base of the next rectangle runs from 1 over n to 2 over n. The base of the next one runs from 2 over n to 3 over n. All the way up to the last rectangle has a base n minus 1 over n to n over n, which equals 1. So that's the base of each rectangle. Okay? Now, I have to decide what the height of each rectangle is. Okay? So what I'm going to do is I'm going to go to the right bottom corner of the rectangle, and I'm going to draw a line up until it hits until it hits the triangle again, the boundary of the triangle. and that's on the line y is equal to x, right? So I'm going to draw that line up, and then I'm going to draw the top, and I'm going to close it to give me my rectangle, okay? So the first rectangle, we said its base runs from 0 to 1 over n, okay, on the x-axis. Now I'm going to draw from y equals 0 at 1 over n till it hits the line y is equal to x, okay? When it hits the line y is equal to x, what is the value of y?
1 over n.
1.
1 over n, okay?
1 over.
Then I draw the top has a width 1 over n, and then I draw a vertical line down, okay? So the first, the first rectangle has a width 1 over n, and it has a height 1 over n, okay? The next rectangle, it runs from 1 over n to 2 over n. So it has a width 1 over n, and then from x equals 2 over n, I draw a vertical line up until it hits the line y equals x. So what's that point? Y equals what?
2 over n.
2 over n, right? Then I draw the top of the rectangle has a width 1 over n, and then I draw a line down. That gives me my second rectangle. Okay, there's a question?
Sir, yes, sir, is 1 over n the height of the rectangle here?
Yeah, 1 over n will be the height of the first rectangle. What's the
So
height?
how did we find it, sir? How did we find it?
We drew a line from the bottom, where x is equal to 1 over n. We drew a line up until it hit the line y equals x, which is the top of the triangle, right? So if y is equal to x and x is equal to 1 over n, then y is equal to 1 over n, right? The next one, the corner was at x is equal to 2 over n. So we drew a line up until we hit y, and there y is equal to 2 over n because y is equal to x. Okay. So that gives you the second rectangle. What about the third rectangle? What's the height of the third rectangle?
3 over n.
3 over n, and so on and so forth, right?
Sir, but the base of the rectangles remains 1 over n now. All of
the
them.
base of the rectangles is always 1 over n. Yeah. Okay. So, once again, the width of each rectangle is 1 over n. Okay. So, the bottom corners of the rectangles are at the points x equals 0, x equals 1 over n, x equals 2 over n, all the way up to x is equal to n over n. The heights of the rectangles are 1 over n, 2 over n, and so on, up to n over n. Okay? The area of the kth rectangle, okay, the height of the kth rectangle was k over n, and the width of the kth rectangle, of all the rectangles, in fact, is 1 over n. Okay. So the total area of the rectangle, of the kth rectangle, is k over n squared. Okay? Now, if I want to add up all of these areas, what do I have? I have the area of n rectangles is equal to summation k equals 1 to n. The height of the rectangle is k over n. And the width of the rectangle is 1 over n. Okay? So if I simplify that expression, that's summation k equals 1 to n of k over n times 1 over n. Now, n is a constant. We have n rectangles, and that's not changing in the problem. So I can pull out 1 over n squared. So that's 1 over n squared times summation k equals 1 to n of k. But we had a result for summation k equals 1 to k, right? That's 1 plus 2 plus 3 up to n, which we said was n times n plus 1 over 2. So that area is 1 over n squared, n times n plus 1 over 2, okay? And I can simplify that as 1/2 plus 1 over 2n, okay? Now, the idea is that if I have just a few rectangles, their area and the area of the triangle are somewhat different. But if I take more and more rectangles and I make the width smaller and smaller, then hopefully I get a better and better approximation to the area enclosed by the triangle. Okay? And then what we do is we say, in the limit as n goes to infinity, right? Hopefully we can approximate the area exactly. We say the limit of the area of the triangle is the limit as n goes to infinity of 1 over 2 plus 1 over 2n, right? So as n goes to infinity, the width 1 over n is getting vanishingly small. So I'm taking more and more rectangles. They're getting thinner and thinner. They're approximating the area under the curve y equals x better and better. And if I take that limit, well, 1 over 2n is going to 0. So the limit of this area of covered by n rectangles as n goes to infinity becomes 1/2. And that's what we understand is we already know is the area of the triangle. Okay?
Sir, are we keeping the width constant or are we keeping the height constant?
No, we're going to keep the width constant to get the area covered by n rectangles, and then we allow n to go to infinity.
Okay.
Okay. Any other questions? Okay. All right. Now, what we did was we said draw a line from the right endpoint, right? So we have all these n subintervals, which are the base of the rectangles. And we drew our line up from the right endpoint. What happens if we draw the width up from the left endpoint? Okay. Well, so what I'd like you to do as an exercise to see if you understand what we did before, go through this again, except you draw the height up and draw a line from the bottom left corner of the rectangle up to until it hits the curve y equals x. Okay? You should get the same result, of course. Okay? Now we're going to try the area under a parabola. Okay? So you have the area which is bounded by the x-axis, the curve given by y equals x squared, and the lines x equals 0 and x is equal to 1. So the area under that portion of the parabola. Okay? So we call this the area under the curve from x equals 0 to x is equal to 1. All right. So can you tell me, so how are we going to do this? Give me the rough idea of how we're going to do this.
So we're gonna integrate this and then take the limits.
We're gonna draw rectangles underneath this curve. We'll draw n rectangles, okay? And
instead of the line y equals x, we'll use y equals x squared.
yeah, the height is going to be given by y equals x squared. Okay? So The interval is the same. The base of this figure, the base of this area is running from x equals 0 to x equals 1. Okay? So the notation for this is, now this is a definite integral. Previously we did indefinite integrals. The notation for this is integral from x equals 0 to x equals 1 of x squared dx. Okay? We'll see why this notation in a bit, but
Sir, what's the difference between definite and indefinite integrals?
well, the indefinite integral is like an antiderivative. You're saying what function, when I take its derivative, gives me this integrand. Here, what you're saying is, if the top of your curve is given by the line, but if is given by y equals x squared, and the bottom runs from x equals 0 to x equals 1, then what's the area under the curve? So the indefinite integral gives you a formula. It gives you some function of x. And the definite integral gives you a number.
Okay, sir. Got
Okay?
it. Thank you.
And we'll see how they're related in a bit. That's why the notations are very similar, all right? But that comes a bit later. Okay, so once again, you're running from x equals 0 to x equals 1. So you're going to divide that interval up into n subintervals. And those subintervals are going to be the bottom of your rectangles. Okay? So you're running from 0 over n. So the points, which are the corners, the bottom corners of the rectangles, those points are 0 over n, 1 over n, 2 over n, up to the second last point is n minus 1 over n, and the last point is n over n, which is equal to 1. Okay? Now, so we took the total length, which was 1, and you divided by n, because you have n rectangles, and then the width of each rectangle is 1 over n. If we wanted the area from x equals 0 to x is equal to 2, then we would take the width, which was the total length, which was 2, and you would divide it by n, so the width of each rectangle would be 2 over n. If we were running from A to B, then we would take the total length, which is B minus A, and divide it by n, and that would be the width of each rectangle. Okay? All right. So those are the bottom corners of the rectangles. And the bottom corner of the kth rectangle is k minus 1 over n and up to k over n. Yeah, there's a question?
So for width 2, it would still be 1 over n, 2 over n, 3 over n.
No, it would be, the width of each rectangle would be 2 over n. So the first point would be 0. The next point would be 2 over n. The next point would be 4 over n, and so on.
Okay, sir. Thank you.
Okay. All right. So if we agree that the width of each rectangle will be 1 over n. The base of the kth rectangle runs between k minus 1 over n to k over n. Okay. Now, we have to decide how tall the rectangle is. We've worked out its width. How tall is the rectangle? And what you want to do is you pick any point on the subinterval, and then you draw a line up until it hits the curve y equals x squared, and that's the height for the rectangle. So let's decide that that point is going to be this corner k over n. Okay, that's the right end point of the subinterval, is k over n. So if x is equal to k over n, then y of x is equal to y of k over n. Well, y of x is x squared, right? So y of k over n is k squared over n squared. Is that okay?
Yes.
Yeah. Okay. So the width is 1 over n of the rectangle. The width is 1 over n of all the rectangles, including the kth rectangle. And the height of the kth rectangle is k squared over n squared. Okay. Okay, so what's the area of the kth rectangle?
So base multiplied by height, which is 1 upon n multiplied by k squared upon n squared.
That's right. Right. The width is 1 over n times the height, which is k squared over n squared. Right. So once again, the area of the kth rectangle is its width, 1 over n, times its height, which is k squared over n squared. Okay. Then the area is given by adding up so we are approximating the area enclosed by this figure, whose top is y equals x squared, right? And whose bottom is the x-axis from 0 to 1. We're approximating the area enclosed by that figure by the area enclosed by the rectangles. And the area enclosed by the kth rectangle is 1 over n times k squared over n squared. So we add up from k equals 1 to n, and we will get the area enclosed by these n rectangles as an approximation to the area under this curve. Okay, n is a constant here, so I've got 1 over n cubed times summation k equals 1 to n of k squared. Well, all right, so that's 1 squared plus 2 squared plus 3 squared up to n squared. We said that that was equal to this formula 1/6 n times n plus 1 times 2n plus 1. And we multiply that by 1 over n cubed. And that is the area enclosed by the n rectangles. Now, I can expand that out to give that the area of all of the rectangles is 1/3 plus 1 over 2n plus 1 over 6n squared. Now I let my rectangles get thinner and thinner, and I get more and more of them. So more and more rectangles, thinner and thinner, hopefully in the infinite limit, I approximate the area, in fact, exactly. So if I take the infinite limit as n goes to infinity, what does Sn go to?
1 by 3.
1 over 3.
1 over 3.
So this funny notation that we have, the area under the curve, y equals x squared, running from x equals 0 to x equals 1, is the limit as n goes to infinity, 1/3 plus 1 over 2n plus 1 over 6n squared, and that's equal to, you claimed was 1 over 3.
Sir?
Yes.
Yes, sir. I wanted to ask that can we use the integration method too, or would we have to use this method in the exam only?
Okay. All right. So what we're doing here is called Riemann integration, right? So if you're asked on the exam to find the area under a curve using Riemann sums, then you use this technique, okay? But we have this result of Newton and Leibniz, which is called the fundamental theorem of calculus. And the fundamental theorem of calculus says that you could find the antiderivative of x squared. So you could calculate the indefinite integral of x squared, which is 1/3 x cubed. And then you could evaluate it at, take its value at 1, subtract its value at 0, and that would give you 1/3. So you're right. You can find the area under curves using integration, right? But the we don't know that actually that we can do that until we see the fundamental theorem of calculus.
Okay.
Okay. Yeah. Are there more questions?
So is it all for today?
Yeah, this will be all for today.
Okay, sir,
Okay.
thank you.
So then, what you should do is maybe you for different. I mean, we use these results for the sums. You may not always be able to use these results for the sums, but what I'd like you to do is, I picked an easy interval from 0 to 1, right? So what I would like you to do is I would like you to take an integral, I would like you to take the interval to be from, say, 1 to 2. Okay? And taking the interval from 1 to 2, and let's say using the curve 1 plus 2x. Okay? So you have this curve given by the graph y equals 1 plus 2x, and you want the area under that from x equals 1 to x equals 2. Okay? So I would, what you should do as an exercise to test if you understand this idea of Riemann sums, I would like you to try and calculate the area under that curve, okay? And if you can do that, then probably you understand what the idea is. In fact, don't make it the interval from 1 to 2. That's still length 1. Make it the interval from 1 to 3. Okay? So the area under the curve, y equals 1 plus 2x, as x goes from 1 to 3. Try that, okay?
Sir,
Yes.
so if we end up with k cube or k to the power of 4, like, then do we have identities for those,
Yeah,
the summations?
we do, but I think what you should actually do is then just leave it as a sum right now, okay? If you try working
Okay,
with
sir.
something like that, just leave it as a sum for now. Okay.
Sir,
All right.
can you please
Sir?
explain how we found the height of the rectangle under that parabola thing?
Sorry, can you shout your question, please?
Sir, can you please explain how we found the height of the rectangle under the parabola?
Yeah. Okay. So what we did was we said, here's the point, and let's say the point is k over n. Okay. Now draw the right side of the rectangle from y equals 0 and x equals k over n up to the curve until you hit the curve. Well, you hit the curve at y equals x, the curve is y equals x squared. So when you hit that point on the curve, so y is equal to x squared, but what was x? X was k over n. So y equals k over n quantity squared, which is k squared over n squared.
Thank you.
Okay. Right.
Sir?
Yes.
Sir, I wanted to clarify that definite integral is when we have limits upon an integral, and an indefinite is when we do not apply limits and we just take the integrate of a function, right?
That's right. That's right. The indefinite integral gives you a formula in terms of x. The definite integral gives you a number. It gives you an area under a curve.
Then, sir, what's the difference between an indefinite integral and antiderivative?
They're essentially the same thing.
Okay, sir.
Also,
Yeah.
are the weightages for the midterm and assignment updated?
I don't know. I haven't heard that.
Because I think they were updated to 30% for assignments. I don't know. I just wanted to confirm, like.
Okay, I hadn't heard that.
Actually, it was a misprint, my friend. It was the midterm which was accidentally written as assignment. Your midterm is 30%.
Okay.
All right. Any other
What
questions?
is the weightage for midterm, final, and the homework? So can you please tell that?
I think the final was 60, the midterm was 30, and the homework was 10, I think.
Yes, sir. It's like this. So when we are supposed to like get back our midterms,
I'm still marking them.
and sir, how are they like in
It's
terms of
taking a
performance?
long time.
Okay, sir.
It's a lot harder to mark up PDFs than to just mark on a paper. It's a lot faster on paper.
Yes, sir.
Sir, what
Thank
if we have missed a homework and we just do it sometime late? Like we have late submissions for that. What if?
Well, I mean, we're not. We'll probably drop a sufficient mark to a sufficient number of marks that it would be like the equivalent of dropping one assignment.
Okay.
Okay. Any other questions? All right, then I will see you on Thursday.